In mathematics and computer science, an algorithm is a finite, precise set of instructions designed to solve a specific problem. While heuristics operate as intuitive guidelines with no guaranteed outcome, algorithms rely on deterministic execution to ensure a specific, correct result every time. This animated diagram compares a flowchart for a baking recipe to a data sorting sequence. Both are algorithms. Any replicable process, from cooking a meal to tying your shoes, applies algorithmic thinking outside of digital code. This finite precision eliminates ambiguity. It allows both humans and machines to flawlessly replicate complex tasks. This timeline traces the origins of systematic mathematical procedures back to Babylonian formulas in 2500 BC. By the 9th century, the mathematician Al-Khwarizmi shifted the focus of algebra from finding specific numerical solutions to developing general procedures for reduction and balancing. The translation of his work into Latin introduced the name algorithmy, which eventually evolved into the modern word algorithm. Algorithmic thinking is a mathematical innovation developed by humans millennia before the invention of the digital computer. In the mid-19th century, Ada Lovelace designed the first algorithm specifically intended for mechanical processing on Charles Babbage's analytical engine. In the 1930s, mathematicians Alan Turing and Alonzo Church developed the Church-Turing thesis to formalize the concept of effective computability. This diagram models a Turing machine tape converting input symbols. Their work proved that any method a human could effectively calculate could also be executed by a theoretical machine model. Translating mathematical procedures into strict machine logic provided the operational foundation for modern computing. Today, algorithms automate global infrastructure. They drive cryptography, parse data, screen human resource applications, and determine financial credit scores. Advanced machine learning models present a black box problem. They process data and output decisions through complex pathways that remain opaque to their developers. This diagram illustrates the structural risk. When an opaque model is trained on biased historical data, it scales those existing prejudices, directly producing discriminatory outputs. Deploying these systems at a global scale without independent oversight risks hard-coding human prejudice into the infrastructure of society. This list outlines the necessary regulatory interventions, mandating information disclosure, requiring independent algorithmic audits, developing transparency tools, and conducting continuous ethical impact assessments. Algorithms dictate the flow of modern information and resources. Implementing strict governance frameworks ensures this computational power operates with accountability and precision.